Today we're going to look at the composition of functions. What does it mean to compose functions? It basically means we're taking a function and putting it inside another function. The symbols or symbolically what that looks like here is this here. It kind of looks like parentheses. Does not mean times, so this is not read as f times g. Remember with evaluating, you probably would be seeing the dot symbol instead, if that was the case. So this does not mean the same thing here. This means a composite. Another symbol they use is an open dot, which is separate from the filled in dot. So this means compose. G goes into the F function. So composing a new function by infusing old functions into another. Sometimes we're given an actual x value to put in first, or sometimes we're not, but in the case that we are given a numerical value, it would be written like this here, or like this. So the two-step process would be substitute the value, the x value, into the innermost function and evaluate, take the answer in the first step and put it into the next outside function. We're always working from the inside out, So here G would get evaluated first. The answer that comes out after 2 goes into G goes into the F function. If you're not given a value for x, you're simply substituting the entire innermost function into the function next to it, the next outer function. And simplify with orders of operations, your answer will have x's in it. Here we have 3 functions. We have an f function, a g, and an h. And we're just going to do some composing with various examples. So here we're given f of g of 5. That means we're given a numerical value, 5, to put into the g function, and that's the first step we're going to do. So g of 5 becomes 5 squared, which is 25. Then we're supposed to take that answer and put it into the f function. We're always working inner to outer. So now that we have a number for g of 5, we put it into the f function. So f of 25 becomes 3 times 25, which equals 75, and that is the answer. Another example, h of g of f of negative 2. So you're always working from the innermost to the outermost. We're going to take f and plug in negative 2 and evaluate. So 3 times negative 2, which is negative 6. Now we're going to take that answer and put it into the g function, because that's the next outer function, working our way out. So negative 6 squared is 36. Then we take that answer and put it into the h function. H of 36 is negative 4 times 36 plus 1 equals, and the answer to that is negative 143. In this example, we don't have an actual value to put in for x, so we're simply taking the h function, still in terms of x, and putting it into the g function. So when you're looking at the h function, you're taking this entire thing there, and it's going to go into the g function. So the g function is basically something squared. So in that something, that x there, that gets replaced with negative 4x plus 1. And of course, we know how to evaluate this. So we're going to expand this and FOIL. So that will come out to 16x squared minus 8x plus 1. Another example of a composition working from the innermost to the outermost. So we're taking the g function and putting it into h. So now g is the x squared, and it's going to go right here into the h to replace the x. It's always about replacing x with something. So that is the first step here, putting g into h, and it's pretty much simplified. I'm just going to take out those parentheses. This is a negative 4x squared plus 1. And now that result is now going to go into the f function. So here's our f function, 3 times x. Instead of x, we're putting all of this. So now this is going to say 3 times negative 4x squared plus 1. And then we simplify. Distributive property is negative 12x squared plus 3. And we're done.